Hi, everyone. Let's get started. Thank you all for coming. My name is Alex Buckley, and I work in the Java Platform Group at Oracle. Welcome to Tip and Tail, the release model for Java. I need to say one thing at the beginning. This is not a technical talk. There are no language features, no code samples, no demos. This is a talk about how software creates value in an organization. The software comes from you, application developers, and from library developers, and from JDK developers at Oracle. The value comes from aligning your needs as application developers with what's provided by library developers and JDK developers. More concretely, this talk is about the stack of code that your application relies on all the way down to the JDK, and the costs and benefits that arise when that stack of code is changed. So before I go any further, let me define what I mean by release model. A release model is a set of rules for evolving and publishing a piece of software. Every project, whether it's an application or a library or the JDK itself, defines these rules to govern when the software is released, what kind of changes are allowed in each release, and how older versions should be maintained and released, if at all. These rules cascade down into details about versioning and licensing and testing and tooling and so on. But the core idea of a release model is to put some structure around change in software so that users can make informed decisions about whether the changes meet their needs. With that in mind, I'll talk first about how you use Java to meet your needs. Then I'll talk about a very widely used release model, one size fits all, and why we think it's not as useful as it once was. Then I'll introduce the tip and tail release model, which will seem familiar because it's what the JDK uses. And finally, I'll talk about the adoption of tip and tail by libraries in the Java ecosystem and how it will help you as application developers. So, how do you use Java? Let's start with your application. You might think of it as having, say, 4 dependencies, but each of those has dependencies of their own, and of course, everything ultimately depends on the Java runtime. Some people are running on Java 8 today, and 5 years from now will be still running on Java 8. There's nothing special about 5 years, it's just meant to be a medium-term horizon for how Java is used in production. Please raise your hand if this is you. Some hands. Lots of people have upgraded from Java 8 to 17. Over the next 5 years, I think they will mostly upgrade to Java 21 as the ecosystem's center of gravity drifts forward, like it did from Java 6 to 8 and from 8 to 17. Please raise your hand if this is you. Slightly more hands, quite a lot more hands. And finally, some people are running the latest Java release. Java 24 was released today, and it's production ready. If you liked Java 23 last week, you'll love Java 24 this week. 5 years from now, you will be running Java 34. Please raise your hand if this is you. Excellent. Lots of hands. Some hands. So the user base that runs Java 8 both now and in the future is real. I saw hands, but it's largely invisible. It tends to be locked inside large enterprises, running production systems for many years with little maintenance needed. These users value stability above all else, upgrading as little as possible over time. If you raised your hand for 8, does that seem vaguely sensible? Yes. Let's go with yes. Meanwhile, the user base on Java 17 is large and growing. Many libraries have adopted 17 as their minimum runtime in response to the sense that many people have, which is that many other people are on 17. But no one using 17 plans to use it forever. Maybe you'll want to use a new Java language feature like pattern matching, or a new API like stream gatherers, or a new garbage collector. Maybe the libraries you depend on will adopt 21 because they want to use new language features and APIs. At some point, no reason to upgrade becomes no reason to stay. Then you'll want to move from one tried and tested version of Java to the next, knowing that while the upgrade may be some work, the result will be worth it, just as previous major upgrades were worth it for you. In other words, if this is you, when you upgrade, you value predictability, specifically the ability to predict that a newer JDK will be worth the effort. And finally, those of you running the latest JDK are all about maximizing your productivity and your performance. You've got all the new APIs, such as the foreign function and memory API and the class file API. You get continuous functional improvements like code snippets and Markdown in JavaDoc. I heard a ripple of applause for the Markdown in JavaDoc in the keynote. You get the removal of pinning for virtual threads. You get the widest choice of garbage collectors and observability features. You get all of the bug fixes and all of the security patches. And you stay on top of changes in the direction of Java, such as integrity by default. In short, if this is you, you value functionality above all else, and you will upgrade as frequently as necessary to get it. Looking at things another way, if you value stability, then you don't want or need that kind of new functionality in anything you depend on. It's irrelevant to the application code that you are maintaining. If you value predictability, then you might personally be interested in new features of libraries or the JDK, but you don't need those features today. But if you value functionality, then you're actively excited to embrace new features in libraries and JDK. You don't just want them, you've been waiting for them eagerly. You need them for the next release of your project. How about bug fixes? If you value stability, you might want some bug fixes, but you don't always need all of them. Your application might long ago have worked around a bug in a library or in the JDK, so a fix isn't as necessary as you might think. If you're interested in predictability or functionality, you probably want and need as many bug fixes as you can get as soon as possible. There's no reason not to. Now, security patches are important to everyone. And this includes even the most stability-minded users. If your application is so deeply embedded in an organization that it must keep running without change on Java versions from many years ago, then security patches are essential to keep bad actors from taking control of your application and changing its behavior. So we've seen that application developers value different things: stability, predictability, functionality. And developers who value different things want and need different things, both from libraries and the JDK itself. Let's see how library developers try to keep their users happy. One-size-fits-all is a simple release model where library developers try to ensure that every release of the library meets the needs of every user. To do this, library developers include a mix of updates in every release. They put in new features, they add functional enhancements, they have bug fixes, security patches, performance improvements, anything you can imagine. And maybe there's a versioning scheme that describes the scope of the changes, but as the library rolls forward, there is a good version that library developers ultimately expect users to upgrade to. That's what gets all of the effort. And what this means is that a library, following one-size-fits-all, has to support a wide range of Java versions in order to serve a wide range of users. The library developers choose a lowest common denominator version of Java that we like to call the baseline, and they can only use Java features available in that baseline. Now, this turns out to be frustrating for everyone involved. Let's look at the evolution of a hypothetical library over time. So there's a library, version 1. This is not meant to be any specific library. This is just seeing how these things roll. It's the early 2000s, early to mid-2000s. It's baselined on JDK 6, and the library evolves. A new JDK appears a few years later, and a new version of the library appears. And this question comes up, should we baseline on JDK 6? No, people aren't interested in 7. It only came out last year. Let's keep baselining on 6. And the library evolves. Time moves forward. JDK 8 appears in 2014, over 10 years ago now. The question arrives again. Should we baseline the new version of the library on 8? Well, it's nice, but it's too new. People aren't using it. Let's just leave it on 6 for now. And this keeps going. New JDKs appear, the library moves forward, it has new features, new versions of the library maybe remove some old fixtures, they fix bugs. Even newer JDKs appear. Eventually, this eternal discussion about baselines leads the development team to say, okay, JDK 7, more years roll forward, maybe eventually in 2021, 7 years after 8 came out, we can finally baseline on JDK 8 because now, at last, most people are on 8, and most of the development team says, thank you, I can finally use lambdas in the implementation. This debate about baseline in one-size-fits-all is eternal. Now, this is bad for users who value functionality. Baselining on old JDKs locks the library out of new Java features. A library baselined on JDK 8 can't use any of these features. Its implementation is not as good as it could be, and its API is not as expressive as it could be. So this hurts users who want to embrace new functionality in Java and use it to boost their own productivity. At the same time, baselining on old JDKs to help users who value stability and cannot upgrade will eventually backfire. Because as time goes by, the library evolves, it gains new features, enhancements, bug fixes, etc. It's one size fits all. None of this is backported to anything. And users who value stability don't want to upgrade because they will not use the new features. And they may even rely on features that have been removed in version 5. But there will come a time where those stability-minded users have to upgrade for security reasons or to get a critical bug fix. It is inevitable. And it will be awful for them. And they may very well, in order to upgrade to a much newer library version where the bug fix exists, have to upgrade their JDK as well. These users want as little change as possible, and yet eventually they will find themselves having to change everything. So one size fits all is good in the early part of a library's life cycle as it's evolving, as it's gathering new users. But once a library has many users, their needs become diverse, even contradictory. Now, to address these diverse needs, some libraries, the big popular ones perhaps that can afford it, offer multiple release trains. So imagine, in our complicated hypothetical example, imagine it's 2021, that's when version 5 of our hypothetical library is released. Version 5 is released. Is the 4.star train going to be maintained for a few years? Probably. How about the 3.star train from 8 years earlier? Unlikely. And that 1.star and 2.star train from 10 years earlier? No chance. And it's funny because satisfying the users of those earlier versions was important enough for many years to keep the library baselined on an old JDK where those users lived, where the library had originally come out. Baselined on JDK 6 for many years after 8 came out, but eventually, under one size fits all, and even if you do multiple release trains in the normal way, those users are abandoned, those application developers. So multiple release trains can help to satisfy users who value functionality because there's always a current release train with new features, but it does little for users who value stability. So this brings us to tip and tail. Tip and tail is a release model. We think it gives application developers a better experience, and at the same time helps library developers to innovate faster. Tip and tail is defined in JEP 14. If you haven't come across them before, a JEP is a JDK enhancement proposal. The vast majority of JEPs are about new Java features, but some JEPs are meta. They describe the process that we use to enhance and evolve the JDK. JEP 14 defines tip and tail as a streamlined and disciplined form of the multi-train model, where only one release train draws nearly all the work. Library developers offer a release train called the tip. Releases in the tip train are about moving forward. They improve the productivity of users building new systems and applications by providing new features, functional enhancements, along with the largest possible set of bug fixes, security patches, and performance improvements. From time to time, library developers designate a tip release as the start of a new tail train that they will continue to update even after new tip releases are made. Releases in a tail train are about preserving the status quo. They satisfy the needs of users focused on stability by offering critical bug fixes and security patches and nothing else. So the tip release of a library gives you everything. Tail releases contain only critical bug fixes and only security patches. Here's a moment in time of our hypothetical library that's up to version 5 using tip and tail. The tip release in green is 5.0, and there are 4 tail trains, 4.2, 3.1, 2.6, and 1.3. These tail trains undergo very little change, which means they're easier to maintain, which means tail releases can be pumped out for much longer than in the traditional multi-train model. If you value functionality, the tip gives you everything. All the new features, all the bug fixes, all the functional enhancements. If you value predictability, tip and tail gives you new options. Suppose you run the 3.star releases and you don't want to jump all the way to the 5th generation of the library. Maybe too many APIs were changed. Maybe features were removed. You can stay on the 3.1 tail for a long time, or if the benefits outweigh the costs for you, you can upgrade to the 4.2 tail. I'm not saying that the upgrade from 3.star to 4.star will be trivial, but it will definitely be easier than chasing the latest generation in the tip. And if you value stability, then having tails that are updated for years, maybe even decades, is a huge win. Suppose you run 1.star or 2.star releases and you can't upgrade from JDK 6. Having access to the 1.3 tail and the 2.6 tail preserves your investment while minimizing change. So in the nutshell, we like to say that tip and tail gives you what you need and doesn't give you what you don't need. And this is true whether you value functionality or predictability or stability. That's the view for application developers. What about library developers? The mantra for library developers is simple. Add new features only in the tip and backport as little as possible to the tails. Backporting as little as possible is the discipline that distinguishes tip and tail from traditional multi-train release models. It means backporting fixes for critical bugs that could cause applications to malfunction catastrophically, such as incorrect mathematical calculations. It means backporting patches for security vulnerabilities. And if a library depends on external data sets from governments or industry bodies, then it may be necessary to backport those as well. But that's it. That's a minimal approach. It means that the churn in those tail trains is reduced. And this is good for users who value stability because the updates are lower risk. It increases, in all probability, the number of tail trains, since the cost of maintaining each tail train is low. And this is good for users who value predictability, since they can move forward in and among the tails at their own pace. And of course, it reduces the time invested by a limited, likely open source library development team in the tail trains so that more time and effort can be put into improving the tip train. And that's obviously good for users who value functionality because they get more new features faster. A library developer recently pointed out to me that the effort to backport grows with distance from the tip. Backporting to the most recent tail might be straightforward, but backporting all the way from 5.star to 1.star is probably very difficult. But good news, users of older tails do not want a lot of backporting. They want stability, not change. So almost nothing needs to be backported from 5.star to 1.star, only truly critical bug fixes and security patches. So as a result, the interests of users who want little change and the library developers who don't want high effort are aligned. Now, tip and tail still leaves plenty of decisions to the library developer. It doesn't specify when or why tail trains are created. It doesn't control or govern when or why they are discontinued in your project. It certainly doesn't specify anything about how releases are versioned or licensed. And in particular, it doesn't require that the tip release of your project has to be baselined on the very latest tip JDK. For example, the tip train of your project could target JDK 21, while tail trains target likely whatever they targeted when they first appeared, 8 and 17. Or a library could say that every train is going to target JDK 17, if that's what's best for that library's users. So there are plenty of discussions for library development teams to have to adopt tip and tail, and we say nothing about concrete practices, versioning in particular, that might hold up that adoption. Now, in the JDK, we adopted tip and tail back in 2017. This slide will look familiar, but now the versions are real JDK versions. The tip release of the JDK at the top is now 24. The tip release contains all the new features that are ready. As it happens, there are 24 JEPs in JDK 24, delivering major new features like the Stream Gatherers API and new security APIs, and literally thousands of functional enhancements, bug fixes, security patches, and performance improvements. In addition, Oracle maintains 4 tail trains, 21.0, 17.0, 11.0, and 8U. That's why you hear JDK 21, 17, 11, and 8 described as long-term support releases, because they are tails. If you're interested in predictability or stability, you should be running 21.06, or 17.014, or 11.026, or 8U442. Just because you use a tail release doesn't mean you don't have to upgrade. Quite the contrary. You should be upgrading just as frequently within your favorite tail train as someone who is following the tip train. Otherwise, you're using a tail train and not getting the benefit of the limited patches and fixes that it's providing to you. Now, the low cost of maintaining tail trains means that Oracle JDK 8 will receive updates until at least December 2030, 16 years after it was released. Oracle JDK 11 will receive updates until at least January 2032, 14 years after that was released. The fact that users can get tail releases for so long, even for a huge project like the JDK, is testament to the efficiency of tip and tail. Another example of a library that practices tip and tail is Spring Boot. New features are added only in the tip train. Only bug fixes are backported to tail trains. Like the JDK, there's a new tip release every 6 months, 2.7 and 3.0 in 2022, 3.1 and 3.2 in 2023, and so forth. And tip releases are forked regularly to create tail trains, which generally are short-lived in their model. But the tip release that represents the end of a generation, such as 2.7, and I believe now 3.5 has been announced like this, that becomes the root of a tail train that is maintained for much longer. So let's review. In a nutshell, tip and tail is a streamlined and disciplined form of the multi-train release model for libraries. It gives users exactly what they need, whether their focus and need is stability or predictability or functionality. The JDK adopted tip and tail to provide a balance between rapid innovation in the tip and long-term support in the tails. And we think as more libraries adopt tip and tail, the whole Java ecosystem will become even more attractive for new applications and even more reliable for long-running existing applications. So with that, thank you for your attention and happy to take questions. I think we have 2 mics in the front, yes.
I have 2 questions. First of all, how did you become so good looking? And second of all, on slide 35.
Slide 35,
you had
always enjoy
the backporting.
Specific questions on specific slides. Yes, the library developer for a well-known project pointed out to me that the backport effort varies with distance.
Yes, so could you explain, if you have any experience with the trade-offs, the difference between backporting, say, from 5.0 to 4.2, 5.0 to 3.1, versus is it possible to backport a fix, say, from 4.2 to 3.1 after you've backported it from 5.0 to 4.2? And are there trade-offs? Yeah.
Yes, the question is, so this simple graphic shows the backports all starting at 5 and going directly to much older tails. The question is, in reality, actually, wouldn't you be more likely to go from 5 to 4.2 and then from 4.2 to 3.1 and so on? So the net effect might be that all of that extra work is more difficult, but it's not literally done in one monster. Yes, it is likely, and the JDK does this, that you backport incrementally from tip to the nearest tail. That's easy. Easy, he says, just from the most recent tail to the second most recent tail, okay. Yes, by the time you're backporting from, let's go to, yeah, this is pretty good. By the time you're backporting from 11.0 something to 8U 400 and something, you may not have as many tests as you liked. Maybe the tests that were written for the thing you're backporting in the days of 17, maybe those tests rely on the new version of JUnit and you can't backport them. So those old versions, I mean, you know, we sort of very much hope that as little backporting as possible is needed to the very oldest versions, because all of the infrastructure to build and test will likely have moved on. You know, not even in the tip, but, you know, 3 tails hence. So this is this whole effort to help users who, I don't know how many people are on JDK 6 anymore, but there are any time on the internet where people are discussing new features in Java, someone guaranteed will pop up to remind everyone that they are still on Java 8 over here. It's a real phenomenon, and it will become, we're still on 17 over here. And it will become, we're still on 21 over here. I remember when we launched Java 7 in this very room. Time will move on. People who are on 8 today are likely to be on 8 for the next decade. People who are on 17 today, some people will move on, some people will stay on 17 for the next decade. Those application developers want as long a tail as they can get, with as little change as they can get. So the backporting, different projects are going to approach this in different ways. The JDK has various projects for the tip and for some updates, and then for the very oldest updates. And if you follow the mailing lists, JDK updates dev and JDK 8U dev, you can see the backports flow.
Just kind of a follow-up question. Is there a point where you determine that you don't backport something to an older version, even if that train is still being maintained because the cost is too high or something?
Yes. The question is there a barrier or a gate above which you would not backport something, let me come on to the something, from, well, so is it from the tip to the latest tail, or is it from a tail to an older tail? And also, is the thing that you're backporting, is it just a security fix, a security patch or a bug fix? So we limit, the model says limit the scope, so new features, and there will be people who come to the dev lists for the library and say, please backport, maybe not a new feature, but please backport this API change, this is going to get complicated now, that you made in the 5th generation, please backport that to the 4th generation because I can't upgrade to 5. And the library developers will say, we can't backport that, it's a breaking change. Don't you know what semantic versioning means? And so this is why I talk about users over and over and what are their needs, not their wants, their needs. So if in doubt, don't backport. And if you look at the OpenJDK project page for the 8U project, and you compare it to the OpenJDK project page for the JDK updates project, which is everything above 8 and below tip, so it's 11, 17, 21, you will see a difference in attitude. You will see a difference in how cautious the maintainer of the lead of those projects is with regard to accepting backports. By the time you're down at 8, it's very, very constrained. Any more questions? Yes, please.
Yeah, if you're working in a complex organization and you've got some teams strongly trying to push the latest software into like JDK 21 or even 24 now that it's out. And then on the other end of the spectrum, you might have teams that are totally focused on stability. So have you ever had any experiences using this model to encourage the strong stability components to move upwards to I think you understand it.
Yes, the question is, you have diverse needs within an organization. Even if I want to draw a picture of where one project in an organization might rely on libraries from elsewhere in the organization that rely on further libraries from elsewhere in the organization, all the way down to the JDK, and those different teams have little in common with each other. They have different values. And so it may be that there are teams, let me go all the way back to, this is every Java application in existence. It may be that if the application, I think you said that is more functionality and forward-looking, but the libraries in the middle, either external or internal to the organization, may be a little more stability-oriented. Perhaps they have much less resource than the application. The main thing is to get the typing correct. You can run tail libraries on top of other tail libraries, on top of tail JDKs. You can run tip libraries on tail JDKs. What you mustn't do is run tails on tips. Tails on tails all the way down is ideal. Tips on tips all the way down. If all of the teams line up, they're all using a modern JDK, none of them are relying in their library on features that have been removed, etc. Tips on tips is beautiful as well. You can do tips on tails. What you can't do is tails on tips. So yeah, this is obviously this is a very large landscape, and it speaks to the resource availability and the skill sets and the timelines and the business priorities of internal projects that are using these libraries and that are picking or having picked for them at JDK. So it's a big topic to get your head around, and I would love commentary, especially from the stability-minded users, on you're on JDK 8 today, that's great. Other teams in your company are on 21. We think this is the best approach if libraries adopt it, the JDK has already adopted it, to essentially giving everybody what they need, to keeping everybody happy. I'll stop there, or I'll just keep talking. We talk afterwards? We have a few minutes left. Otherwise, we can go to break, and I'll happy to talk to you afterwards. Thank you again.